Okay, so we're going to start to put some of these skills together now. We've got a line intersecting with our circle. Find the coordinates. Now this is very similar to what we've done before. So I've done this on the side already. And again, feel free to pause the video, have a think, and then see what I do. But we're just substituting this into here. If that then holds true, we factorise and we'll find the coordinates. Okay, so I'll just zoom out for us. Let's have a look. There we go. So I've substituted them, taking time to multiply my brackets out, group the like terms, and then here I've factorised. So if we couldn't factorise, it would mean that this line doesn't pass through. Yeah? If we factorise and get equal roots, it means we've got a tangent. But here we factorise and got 2 different points, sum it back into the original equation, and that's your 2 points of intersection. Now for 5 marks, pretty awesome actually, I would say. Good bang for buck there on the time and effort you're spending on the problem. So definitely worth being able to do some of these skills. Okay, the next one, a wee bit more thinking involved. Okay, so PQ is a tangent to a second smaller circle. It's concentric with the first, so it means they share the same centre. Determine this equation. So a wee bit more thinking involved with this one. Okay, so let's have a little think to ourselves. The first thing we want to say is centre, radius, and then actually wants the equation. So CRE really does make sense this time. Usually it's been CRR, but we need the centre and the radius. So if it shares a centre with this bigger circle, well, I can take that straight from here. So that's just going to be 2 and 3. So right away, fantastic. So just knowing what concentric meant is probably got your little mark there, sharing the centre. To get the radius, so the radius of our circle would look like this, wouldn't it? Go from the edge. Okay, now I know there's not one radius, there's several radius. We have the radius there. That's going to meet that line at 90 degrees, isn't it? Because the radius meets tangents at 90. So I wonder if maybe I could do something with that. If I know the centre is 2, 3, if I could work out this point here, that would then tell me, I could then work out the length. That point there is going to be the midpoint between these two, isn't it? It's going to be symmetrical, it's a tangent. So really for the radius, we're working at the midpoint of PQ first of all. So let's say the midpoint of PQ, and that was my P and Q over here. So I'm going to say that that's 0 plus negative 2 divided by 2, and 7 plus 1 divided by 2. So I'm going to get negative 1 and 4. And again, I like to just double check that makes sense. If I was to put in here, if I write in negative 1, oops, I write in negative 1, 4, let's just check it skips in the same kind of amount. So 0 to negative 1 is taking away 1, and 0 to negative 2 is taking away 1 again, so that makes sense to me. And the 7 and 4, that's take away 3, and then 4 to 1 is take away another 3. Right, so that's good, I've got that right. So I now know the midpoint, and I know the centre. So if I look at this, from midpoint to centre, so I've got 2, 3, and negative 1, 4. If I use Pythagoras, I can work out that length. So horizontally, I am going 3, and vertically, I'm just going 1. Just the difference, isn't it? The difference. So r squared is equal to 3 squared plus 1 squared. So that's just going to be equal to 10. And now I'm ready to do my equation. So take away 2 squared. Y take away 3 squared. Why do we do that? We change the sign, don't we? Change the sign of the centre to give us this. And then r squared is 10, because r squared was the sum of our squares, using that as midpoint. So, you could argue that's quite an easy question. Now you've seen it, but I think when you're given the diagrams and asked to work through that, there's a wee bit of thinking involved, which would throw a lot of people. So, nice question to get in theory. 9 marks there, but some of these can just throw you a wee bit. So, I think the big lesson here is concentric means share a circle and share a centre, and make sure you get your headings in. And yeah, once again, radius meets tangents at 90 degrees. That's a really important point. Well, I know that I'm quite using it to video, but knowing that point, the tangent was going to be meeting the radius, known as on that line is important. Okay. So yeah, hope that's helpful, and we'll try another one in the next video.